Alright guys, so today we are going to solve a system of 3 equations. So in the previous examples we solved a system of 2 equations by graphing, substitution, and elimination. So here we're going to look at a system of 3 equations which now presents 3 unknowns. So we now have x, y, and z. So if we were to graph these, which we're not in this class, but if you were to graph these are 3-dimensional lines. So looking at these 3 equations, we have a lot more work to do because we need to find the intersection of these 3 planes. All right, so looking at this, the first thing I do is I label my 3 equations, equation 1, equation 2, and equation 3. Alright, so I have equation 1, equation 2, and equation 3, and I'm using Roman numerals just so I don't get them confused with the coefficients. Alright, so we are only going to solve 3 equations using elimination method, and then later we're going to learn how to use matrices. So looking at the coefficients of all of the x's, we have 1, 5, and 2. The coefficients of y are -2, -4, and 3. And then the coefficients of z are -1, 1, and 1. We're going to use the elimination method, but we have to choose which variable we want to eliminate first. When we did elimination with 2 variables, we just had to eliminate one of them, and then we were left with the equation of just 1 variable. So when I rattle off the equations of the coefficients of x, the coefficients of y, and the coefficients of z, which coefficients sound to be the nicest ones with each other? If you said z, you are correct. So we are going to eliminate z. So by doing that, we need to do a combination of these 3 equations. So equation number 1, the coefficient of z is -1, and the equations of 2 and 3, the coefficient of z is +1. So we're going to add equation 1 and equation 2 together to eliminate z in those 2. Alright, so I wrote down equation 1 and equation 2, and we eliminate z here by adding the 2 equations together. So it's 6x minus 6y equals 0. Alright, we're going to hold off on that for a minute. Now we need to still have a combination of equation number 3 because we haven't done that one yet. So z is positive here, so I'm going to add equations 1 and 3 together to eliminate z again. Alright, so here's equation 1 plus 3. Z is eliminated, and we're left with 3x plus y equals 4. Alright, why do we need to do that? We need to eliminate z from all of the equations. We had to use a combination of all 3 equations. Notice equation 1 we used twice, and that's okay. And now we eliminated z, so now we are left in black with 2 equations with just x and y. So now we have a new system for a minute. I'm going to rewrite them all to the right. So the pause, and I'll rewrite them. Alright, I want to make a little bit more space on our board here. Alright, so now in black right here, we have our 2 equations and 2 unknowns. So we have to eliminate again. You can decide which variable you want to eliminate. I'm going to eliminate y just because looking here, this 6 is negative and this y has a +1. I'm going to multiply this bottom equation by 6. So we are going to have 6x minus 6y equals 0, and the bottom equation is going to be 18x plus 6y equals 24. Eliminate y, and we get here 24. X equals 24, so x equals 1. Alright, I eliminated y. You could have eliminated x, that's fine. Alright, in the previous 3 different types where we had a system of 2 equations and 2 unknowns, we had an ordered pair. Here we need an ordered triple, meaning we need a coordinate that has x, comma, y, comma, z. So right now we found what x is. X equals 1. If we tried to plug x back into our 3 original equations, we would have x and y and z being unknown. So what we are going to do is plug in x equals 1 into one of the equations that just has x and y. So I'm going to plug it into the bottom equation. So 3 times the 1 we found plus y equals 4. So 3 plus y equals 4. So y in this case equals 1. We have x, we have y, but we need to find z. Don't forget about that. So I'm going to plug in x and y that we found into the first equation to solve for z. So x minus 2y minus z equals negative 5. X we found out was 1, y we found out was 1. We're solving for z. So 1 minus 2 minus z equals negative 5. We're running out of room. Negative 1 minus z equals negative 5. I'll move the 5 over here. Negative 1 plus 5, so 4 equals z. Or z equals 4. Before we need to check that math. Alright, so now our answer is x comma y comma z. So our final answer is going to be 1, 1, 4. Alright, rewatch this whenever you need to. I'm going to recap right now to go through. We have 3 equations. We labeled them equation 1, equation 2, equation 3. We look at the coefficients of each individual variable to solve and decide which one we want to eliminate first. I chose to eliminate z because the coefficients were negative 1, positive 1, and positive 1. So since equation 1 has a negative, I used equation 1 with equation 2 up top here to eliminate z. And then I had to use equation 1 again with equation 3 to get 2 equations with the remaining 2 variables. You have to make sure you are eliminating the same variable in both of those. Then put them together in black here in the middle of the page, and you choose to eliminate a second variable. I could have multiplied this second equation by a negative 2 if I wanted to eliminate x, but I chose to eliminate y, and that's fine. To multiply the bottom equation by 6, I eliminated y, and solve that equation for x. Once you get a value of your first variable, you go back to your system of 2 equations to solve for the second variable. Once you get 2, you go back to the original 3 equations and plug in both values of the first 2 variables you found to find the remaining one. Alright, I just wanted to go through this since this was complicated, so you can always come back here for this video to check it out. Please let me know if you have any questions, and have a great rest of your day. Thanks, guys.